So, we will see in details in the laboratory test what are all the tests need to be done. That means sieve analysis and other tests like bulkage, organic impurity and all. We will discuss in detail when we do the test. When it comes to fine aggregate, always there is a term used called fineness modulus. What does this fineness modulus means? We are doing a sieve analysis and we tabulate the results in a tabular form, right? That means we take percentage of material retained, cumulative material retained, then we calculate material passing. So, based on material passing only, as we discussed earlier, depending upon 600 microns, we identify which falls under what category, that means which zone. Now, what is the meaning of fineness modulus? That means how fine the material is. When you calculate the fineness modulus from the maximum size of material up to 150 microns, whatever the cumulative material retained is available, you just sum it up all, add everything and divide by 100, that is a number. Okay. Suppose you have a value of 274, what you are getting from 4.75 to 150 microns, 274 by 100, 2.74 should be the fineness modulus of the sand what you use. Normally, the most fit sand for concrete making is in the range of 2.6 and 2.8, most fit. But in general, the fineness modulus range can be between 2 to 3.2. In case if you have a fineness modulus range between 2 to 3.2, the sand can be used for concrete making. In that aspect, it helps us. And depending upon the fineness modulus, the substitution level of sand also comes in picture when we do the mixed design part. It plays a major part in controlling the excess fines. We should not add an excess sand. In controlling the additional fines what is available, to have a control, this fineness modulus will help us in making a proper mixed design. In general, if you refer this table, as I said, fineness modulus is the cumulative sum of percentage of material retained from the topmost sieve up to 150 microns divided by 100. Normally, coarse sand, that means zone 1 sand, it ranges between the range of 3.7 to 3.1. Medium sand will have a value ranging between 3 to 2.3. Fine sand will have a value of 2.2 to 1.6. Superfine sand will have a value of 1.5 to 0.7. That means, when we talk about the range of 2 to 3.2, even the material can be available from zone 3 to zone 1. Okay. That means, this indicates you can use any sand which is conforming to zone 1, 2, 3 for regular concrete making. Only thing is, when you are using zone 4 sand, we need to do the trial, establish ourselves the sand is meeting to the parameters of the concrete, then only we can use. Normally, when you work in the northeastern states, that means sub-Himalayan belt, like your Sikkim, Assam, Meghalaya, Tripura, these belts, the sand what is available is superfine sand, that means ultra fine or very fine sand, which is conforming to zone 4. Because most of the cases what happened is it is only river collection, because it is being a Himalayan belt, normally blasting is not allowed. So, getting a aggregate is also difficult, and even if you are getting the spall and even if you are crushing it, as we said when we talk about the crushed gravel sand, even if you are taking a gravel from the riverbed and even if you are crushing it, it will be of soft nature and it will have more of mica also. In such phenomena, in such cases, we need to be very careful in doing a mixed design whenever we are working in the northeastern states, okay, in making a concrete, because that is what is available. So, how to go about? Mostly we may have to go with the combination of crushed sand and river sand to make a concrete, or 100% we need to substitute crushed sand for making concrete. Now, we talked about materials finer than 75 microns, which is called as silt and clay, what we said. Test parameter we will check we will explain you how to do the test in the laboratory testing. IS 383 has given certain limitations of acceptance. When you talk about material finer than 75 microns, in case of a natural sand, it can be 3% by weight. In case of a crushed sand, it can be 15% by weight. In case of a mixed sand, it can be 12% by weight. And in case of a manufactured sand, it can be 10% by weight. That means these are the values specified as per the code when you do the test. That means wet sieve analysis, when you do the test, the values has to conform to this requirement. When we talk about deleterious material, again, IS has given in table number 1 certain parameters. It talks about deleterious material in uncrushed, crushed and manufactured aggregate. 3 different parameters have been specified. Various limitation also has been specified. That means coal and lignite, for example, if you take, for uncrushed aggregate can be 1%, crushed aggregate it can be 1%, manufactured aggregate 1%. When you talk about material finer than 75 microns, what we discussed earlier, 3% for uncrushed. Uncrushed is nothing but natural sand. Crushed is crushed sand, manufactured sand. That means 15 for crushed sand, 12 for mixed sand and 10% for manufactured sand. When you talk about shale, natural material it can be 1%, for manufacture it can be 1%, crushed sand there is no shale because it is a rock derivative. Okay. Then total percentage of deleterious material. By doing a test of organic impurity, in case if you find a darker color of the reference solution, the test solution sample with respect to the reference solution, then we need to test the material for deleterious substances. So, the overall deleterious substances what they say is can be 5% for natural sand, 2% for crushed sand and 2% for manufactured sand. This is what is the limitation specified as per the codal requirements. Main thing is, when you talk about deleterious content, mica is the major phenomena. Generally, mica will be available in sand, especially not in the general sand. If you are working in a northeast region or sub-Himalayan region, the rivers carries lot of mica. Okay. The sand, when you do the analysis, most of the sieves we find only mica that is available. That is also one of the reasons, since the sand is also fine and a lot of mica is also available, it is very tricky for us to make a concrete in the sub-Himalayan belt. Main thing is, mica when you talk about, 1% of mica even if it present in concrete or in aggregate, that normally pulls down the 28-day strength by 5 to 10%. That much of reduction is possible even in 1% of mica is available. Mind this thing is, there is no test method available to identify how much of mica is available, because only with the wind spray test, that means what they say is you have to spray the sand with the wind, so the mica will carry. In our case what happens is sand is also fine, sand also will carry because of the fine material. So, we will not be able to identify. There is no specific test methods available to identify how much of mica is available in sand. When you refer to the graph what has been displayed, it talks about the bulking of fine aggregate. You are finding 3 different graphs for coarse grading, medium grading and fine grading. Okay. This clearly shows when the moisture increases, how the bulkage is getting affected. Normally, for a moisture content of 5 to 8%, the bulking can be between 20 to 30%. Okay. It again depends on the grading zone of sand. That means whether it falls under coarse, medium or fine. That means 1, 2, 3. Normally, when the sand is fine, even if we refer as per the graph, when the sand is fine, the bulkage will be high. Okay. Very fine sand bulks even up to 40% with the 10% moisture. Normally what happened is, suppose if the sand is saturated means water is too high, then you do not bulk, because all the air will get eliminated from the sand, almost it is in the saturated condition, nothing will be there, zero, bulkage will be 0. That means beyond certain percentages with the moisture goes, there will not be any bulkage. Okay. When we talk about the moisture content and bulking of sand, you refer to the graph what has been displayed. If you see the bottommost one for crushed sand, suppose if the moisture content is 8%, then there will be a decrease in volume of sand roughly to the order of 25 to 27% normally. Okay. When you talk about fine sand, even with a moisture content of 16%, even if we take, there will be a reduction since 16% moisture means that means almost it is in the saturation level, the bulkage will be to the order of around 12 to 15%. Okay. So, this clearly indicates when the moisture level increases, the bulkage decreases. When the moisture level decreases, bulkage increases. If you see in the initial phase of 4%, even the bulkage is more. Whereas, when the moisture is around 16%, the bulkage is reducing. That means, when the moisture increases means that means it is coming to a saturation point. That means where water content is increasing more, that means it is almost in the saturation point. So, bulking will not happen because all the air will get evaporated. As I said, bulkage is nothing but due to surface tension effect, the particles are getting swelled up. That is what is the phenomena. So, this is a process, natural process. So, depending upon the sand, it varies.